Okay, so we're going to start with this figure here, and then the question is right above it. And so there we see that x is the distance between the rod and the center of the dipole, and then we have charge rod and the dipole moment. Then we're going to go over here, and this is going to be my work. This is just kind of an overview, kind of simplifying it as to how to work all of this out. And so we're going to start off by finding the electric field of the rod, so that we can go in and find the forces, because that is what we're asked to find. And so go in. We know that we're going to start with the attractive force, or that's what I choose to start with. And so since we have a positively charged rod, the attractive force is going to be the negative Q, which is going to give us x minus s over 2 for r. And then whenever we go to find the repulsive, it's going to be positive charge, which is going to be x plus s over 2 for r. And that just kind of makes that simple there. Then we're going to go in and we're going to start to find the electric field. So I did that, simplified that. And then we're going to get, we know that force is equal to negative Q over E. That's a pretty simple equation there. Straightforward with that. And then you just plug all that in. We have Q. We know that it's negative Q and E, so you just multiply those together. And that's going to give you the attractive force. And so that's going to simplify. You do all the algebra there, just kind of plug them in. Negative large Q times little q over 2 pi epsilon naught times xl times 1 plus s over 2x. Okay, and this is where I messed up the most, is trying to figure out, oh, how do I get from here? And I knew that I should have this as an answer, but wasn't sure how to get there. Don't forget to use the binomial expansion. You should have learned that in calculus. If you didn't, just let me know and I can show you how to do that. And then after that, that's going to give you the attracted force, and then we're going to find the repulsive force. Do the same thing there. Multiply E times positive Q, because don't forget the repulsive is going to be positive since we have that positive rod. And then in order to find the total force acting, we're going to do superposition principle, just like we do everything else. The attractive force plus the repulsive force. You do that. I factored out what they had in common, and then that's going to leave you with large Q over little q over 2 pi epsilon naught times xl times negative 1 minus s over 2 plus 1 minus s over 2. So then that's going to go, and it's going to give you what they have in common times negative 2s over 2x. 2's are going to cancel. That's going to simplify to give you this over here. And then, so it's going to be negative 1 to 2 pi e naught, e sub naught, epsilon naught, times qp over x squared times L. Some people are going to ask, oh, how'd you get that P? Got that P from this QS here, because it tells us in the equation, it reminds us that they don't want it in terms of QS, they want it in terms of P. And so that's the momentum. So that's going to be part A. Part B. So part B, we are asked to find the acceleration. And so in order to do that, we need to find the force. And so we are given that we know the electric field of the rod, and that's going to be part of that equation, which is 1 over 2 pi epsilon naught q over L. And that's just the electric field of the rod. So there's going to be more going on there. And that's going to equal to 1 times 10 to the 6 newtons per coulomb. That's given to us in the equation, or in the problem. Then we go from there, and we're going to find the force, which you can see here how I did just of what the electric field was due to the rod. So that's going to be there, because you can split that up. And then you're going to have left over, you're going to have P over x squared, which they give us the numbers for that in the problem. That's 6.2 times 10 to the negative 30 over 0.01 times 10 to the second, but make sure you have the correct units for that. That's going to give you 6.2 times 10 to the negative 20 newtons. And then you're going to do force is equal to force over mass. We got the force from up here. And to find the mass, we're going to use this over here. Make sure it's in molecules. If not, your answer is going to be off. And that is how you find the acceleration.